Okay, alternating quantity is which acts in alternate directions and whose magnitude undergoes a definite cycle of changes in definite intervals of time. While alternating voltage may be generated by rotating a coil in a stationary magnetic field or by rotating a magnetic field within a stationary coil. Dependent sources in an AC circuit is a voltage or a current source may be independent or dependent. A dependent source value will vary depending on the circuit to which is connected. The equivalent circuit of transistor, for example, uses a dependent source to describe its action. Okay. Periodic time. The time by an alternating quantity in seconds traces one complete cycle, which is called periodic time or time period. And the symbol for periodic time is T. This is the thing. Okay. Frequency. The number of cycles per second is called frequency, and the symbol for frequency is F. This is the cycle of the sine wave, which means this one is one cycle, this is two cycle. The formula for frequency is 1 over time. T is represented by periodic time. Okay, if the angular velocity is expressed in radians per second, then the angular velocity is equals to 2 pi over time, periodic time, or 2 pi times frequency. Okay. A peak factor is the ratio of maximum value to the RMS value, while the form factor is the ratio of RMS value to an average value. This is the table below shows the impedance and admittance of passive elements. Resistor for impedance is Z equals to R, while for admittance is Y equals to 1 over R. For inductor, the impedance is Z equals to JWL, while for admittance is Y equals to 1 JWL. While for capacitor is Z equals to 1 JWC, while for admittance is JWC.
Assalamualaikum and hi. My name is NURUL AFIFAH binti ALIAS. I'm from BEEZ section 1/2. Today I will present for my part, which is to explain using multi-sim simulation. Our topic is single-phase AC circuit analysis with dependent source. So this is the question that we have taken, which is to find the value of V0. From the question, as you can see, the circuit is using the dependent voltage source. So I'm going to show you the multi-sim that I already construct the circuit for the simulation. And I'm using AC power, resistor, capacitor, and this is dependent voltage source. The voltage controller is connected between resistance R2 and capacitor. And for AC circuit, we able to use oscilloscope to get the graph. The oscilloscope have to connect with the circuit, and this is how I connect my oscilloscope, which is channel 1 I connect before the resistor 1 and channel 2 before the dependent voltage source. And for find the value of voltage, I'm using the V probe, voltage probe, and I put the current probe here because from the question we have to put the current. So when I run the simulation, I got the value of voltage is 1.54 volt. So from the oscilloscope, we can get the graph, and I will show you the graph that I already get, and this is the result from the simulation. For the yellow one is KEJURUTERAAN and for the blue one is KEJURUTERAAN. The total pressure is 318 microseconds. From the graph, we can get the phase. Of AC circuit, and I'm using the formula which is total delta divided by times equal to x divided by 360 degree. So we have to find x. So 380 micro multiplied by 360 degree and divide by 1.26 milli. So I get 91 degree for the phase. And this is the phase for AC, our AC circuit. And that's all from me. Thank you.
Hi, my name is Lim Chi-Yan. Let me explain the question and calculation that we done for our topics. Single-phase AC circuit analysis with dependent source. Question. For the circuit in the following figure, find current VF and V0T. From given circuit, we know that the angular frequency, which is W, is equal to 5000. V is equal to 6V cos 5000 T, and Vs is equal to 6V with 0 degree. To find the current, we need to find the impedance of this circle. This is the formula to find the impedance, and this is calculated for impedance of C1. So C1 is equal to negative 2 kJ ohms. Since this circle is a series circle, so we just need to do addition. So impedance equivalent is equal to 1K plus 4K plus negative 2Kj equal to 5K minus 2Kj. Using Ohm's law, I is equal to V divided by R. So V is equal to Vs minus negative 10 Vf and divided by R, which is impedance equivalent. So Vs is 6V with 0 degree plus 10 Vf divided by 5000 minus 2000 J. Using the mesh analysis, we know that Vf plus I times negative 2Kj plus negative 10 Vf is equal to 0. So we use this equation to find Vf. So Vf is equal to negative 2Kj divided by 9 multiplied with I. So we put in this answer into the Vf, which is in the answer of current just now. So we get the current is equal to 1.198 amp with negative 2.511 degree. Since we have the value of current, so we can find the value of Vf. So negative 2 kJ divided by 9 multiplied with 1.198 amp with negative 2.511 degree. So we get the answer is 0.266 with 267.48 degree. So V0 equal to negative 10 Vf. So negative 10 multiplied with 0.266 with 267.48 degree. So the answer is 2.663 with 87.48 degree. But what is the question one is V0T. So we change the V0 into the V0T. And V0T is equal to 2.663 V cos 5000 T plus 87.48 degree. In conclusion, in this task, we have learned and mastered the analysis of single-phase AC circuit with dependent source, based on phases with sinusoidal voltages and currents. From the question, we were able to apply the analysis methods and principles that we learned, such as Noether and mesh analysis, Ohm's law, and Kirchhoff's law. We were also able to determine impedance for the capacitor to find current or voltage of the circuit.